Hello students, welcome to Sreenath. So in this video we are going to discuss the chemical effects of electric current, so which is the 14th chapter from 8th class CBSE science subject students. Okay, this is related to physics concept. So chemical effects of electric current. Chemical effects of electric current is the 14th chapter students. Okay, we will discuss this chapter. So before going to start this session, we will see what are the concepts in it. We will just see the overview. After that we will discuss each topic in detail. At the end we are having the summary session. Okay students, that is the thing. So if you see here, so the first topic we are going to learn is, do liquids conduct electricity? So do liquids conduct electricity? So we know that solids conducts electricity, but what about liquids? So we are going to know about it. It is the first thing. The next thing is that students, this all comes under the topic only. Next thing is, next topic is chemical effects of electric current. So whenever the electric current passes, what are its chemical effects? Chemical effects of electric current. So this is another topic we are going to discuss. Okay students, next topic is electroplating. What is meant by electroplating and what are the effects of electroplating, students? So these are the three things we are going to learn in this present chapter, students. That's it. So if you want to just remember this chapter called as chemical effects of electric field current, so there are only three topics: do liquids conduct electricity, and what are the chemical effects of electric current, and what is meant by electroplating. We are going to learn about these three things, students. That's it. Okay, so we'll start this session. Okay students, so these are three topics we have to learn. So have you ever wondered, students, sometimes your parents warn you, don't touch the electrical appliances with wet hands. Why? So if you touch the electrical appliances with wet hands, it is dangerous to you. But why? So at the end of this session you are going to know the answer of that question, students. So previously, what is our previous knowledge? There are conductors, good conductors. So good conductors are what? So these are the materials. Good conductors are nothing but materials which allows current to pass through them. So good conductors are the materials which allow current to pass them. So those are called as good conductors. And what about the bad conductors or poor conductors or insulators? So poor conductors are also the materials which will not allow electricity to pass through them. So these are poor conductors or insulators, what we call it as them. So in the class 6 students, we have made a tester to test whether a particular material is a conductor, good conductor, or a poor conductor. So just recall that that tester, students. So if you see here that metals like copper and aluminum conduct electricity. You know the metals such as copper and the aluminum. This will conduct electricity, students. Okay. And rubber, if you take rubber, it will not conduct electricity. So it is a poor conductor. Rubber, plastic and wood do not conduct electricity, students. So what are the examples of good conductors? If you take here, that copper and aluminum are examples of good conductors, and what are the examples of pure conductors? Rubber, plastic, wood, all these are the poor conductors, students. So if you just see the tester, it is a battery or cell, and it is the bulb, and these are wires which are connecting the bulb and the battery. So if you connect all these them through this screwdriver, so it is a metal. So that's why the current passes through this and it will circuit completes and the bulb will close. Okay students, so this metal, this is the this part is the conductor. It is good conductor of electricity. So we know these wires are good conductors. This battery will provide the electricity. So whenever this electricity produced by battery reaches the bulb will glow. Then we can say, so the current is circuit is complete and the current is passing. This is the situation, students. Okay, that is the case. So this is a metal. Okay, this is in the solid state. Okay, if you say copper, aluminum, rubber, plastic, wood, all are in the solid state. But what about the liquid state? If is any liquid conduct electricity or not? So that is our main question. So we are going to start the first topic, students. That is, do liquids conduct electricity? Do liquids conduct electricity, students? So we have to know about this, whether they will conduct or not. So we know that solids conduct electricity, but what about liquids? So for that also we are going to make tester. So with the help of the tester, we can decide that the material, whether it may be a solid or it may be liquid, which is a conductor or not. That is the thing. Here there is a another tester, students. If you see here, so this tester is now wrapped on plastic, so that's why there is no bulb is not glown. So that's why this plastic is not good conductor. So same kit is placed in liquid, so that if the bulb still glows, even though if you place these wires in the liquid, then that liquid is conducting current. If the bulb does not glows like this, then we can say that the liquid is not good conductor, it is poor conductor. So okay, so before we are going to test, first thing is we have to check whether our tester is working good or not. So for that, what we have to do, students? So while checking, there is a caution while checking your tester, do not join its free ends for more than a few seconds, students. Okay, first thing is, these two are the free ends, students. These two free ends are wrapped around this plastic and wrapped around this metal here. So first thing is we have to check whether our testing kit is working or not. So for that, what we'll do is we will join these two free ends, so that while joining these two ends, if the bulb glows, then our tester is good, it is working. So and don't join these two free ends long time. So if you join like that, the battery will glow, the cell will exhaust, so electricity is removed. Okay, students, that is the case. So first thing is you have to make the tester, students. So if the bulb is not glowing, even though if you attach the both free ends, so there is a problem in the testing kit, the tester. So we have to look for the battery. Does the battery or the cell, whatever it may be, it is having that power to produce the electricity or not. So next thing is we have to look up for bulb. Does the fuse of the bulb is broken or it is still good? If it is still good, and even though if the battery is good, then think of for the wires. So if the bulb and the battery or the cell and the wires are good, then the circuit will be in good condition and it will conduct electricity, students. So after completing the test, after completing the testing this kit, you have to do the task. You have to use this tester to test different liquids. For that, what we have to do is, the students will do this type of arrangement. In a plastic bowl or plastic cap, we will pour water. So we will take 2 or more or 3 plastic cups, students, like this. In all these things, we will pour water. In addition to the water, what we will pour is, the students, in something, in one cup we'll pour lemon juice, and in another cup we'll pour vinegar. In another cup, students, we'll pour some other liquid or pure water, whatever it may be. So what we have to do is, there are two free ends now students. Here there are two free ends. So these two free ends are immersed, dipped in this, dipped like this. So in this situation, if the light glows, then we say that the liquid is conducting the electricity, so that the liquid acts as a liquid is a good conductor. So in this case, if the bulb does not glow, then it is not a good conductor. So basically students, how the bulb glows students, basically what happening is the students, so the cell or battery will produce as the electric current, and it will passes through the wires, and through these wires, if it is the metal, it will passes through it and passes through it, and it comes to the bulb. So in the bulb there is a fuse. So because of that electric current, the fuse becomes heated, so it will reaches very high temperatures and starts glowing, so that our bulb will glows. Okay students, that is the case. So that is the case, that in that way that the bulb will glows. So if you place different liquids students, sometimes it will glows very brightly, and sometimes it will glows dim, and sometimes it glows very nicely, very brightly, sometimes it is glows very dimly students. Okay, all these happens. So whenever the light glows, then we can conclude that liquid is a good conductor. Whenever the light does not glow, it is a poor conductor. That is our final conclusion students. Okay, so but what happening is that students, sometimes the bulb glows for some time and the bulb glow dim for some time, like that some complications will come. So why are they are coming? Why they are coming? Why? Because means then students, so we have already discussed that the filament will heats up, and so the filament will heats up, and it will gives the heats up to high temperature, and it will gives what glows. It will glows and it will gives temperature. Basically that is the thing happening. But what happening is that students, the even though liquids conduct the electricity, but they will not conduct as the metals. So that's why what is happening is that students, so liquids will not conduct as much as metals. That's why the filament does not get that much of heated. That's why that much of current is not passed through the liquids. So for small currents, the light will not glow. So even though liquid is conducting the current, even though liquid is allowing the current, but it is not, the bulb is not glowing, so that we didn't know about it. So for that reason students, we have to need to make another electrical tester to test whether the current is conducting or not. So for that reason, we use another property of the current, that is nothing but magnetic effect of electric current. So we will magnetic effect of electric current students. We will use this concept to develop a tester, to prepare a tester, new tester. So how it looks like is that students, it is looks like this. So we will take a match box, empty match box, and we will place a magnetic compass here, and we will roll some electric current wire here, and we'll connect it to battery. So other end of battery is one of the free end, and other end which comes out of the magnetic compass is another free end. So these two are the free ends. These two are the free end students. Okay, this is the situation. So what is the basic concept is, whenever the current flows, we know that magnetic effect of current, whenever the current flows, it will produce as the magnetic field. So whenever there is magnetic field, the magnetic compass will show some deflection. Okay students, so there will be some deflection, so that magnetic compass will deflect because of magnetic field. So whenever the current flows through this wire, so we can see deflection. So that is the test. By that we can, if you see there is a deflection, we can conclude that current is passing. Okay students, that is the situation. So these two are the free ends students. So we take these free ends and dip in liquid, students. Okay, so that what happens if you dip them in liquids, so this is the cell or battery, whatever it may be, it will produce electricity and will pass through this wire and will goes through the liquid and will pass through the liquid and it will comes to this and it will pass through this. As long as it comes to here, the magnetic compass will show some deflection. That is the case, students. So in this way we use this tester to test whether the liquids are good conductors or not. What is the advantage is the students, even for the small currents also the magnetic compass will show a deflection, so we can find out the small currents also. But in the case of previous tester, small currents are not captured by the filament. That is the drawback. So while doing these experiments, you must have take care, students, that every time you replace the liquid, what we have to do is we have to wash and wipe the dry ends of the tester. After testing each liquid, you have to wash the dry ends of these two dry ends and you have to dry them, and then only you have to use for the second experiment. That is the case, students. And by doing, you have to do with different materials, lemon juice, tap water, vinegar, like this, students. Okay, like that you have to do the, students. So actually under certain conditions most materials conduct, students. That is why it is preferable to classify materials good and pure conductors. So what happening is that, students, every material will conduct in certain extreme conditions. That's why we are classifying the materials as good conductors and poor conductors, not as insulator instead of insulator. Insulator means which does not allow, but even the insulators under certain conditions will conduct electricity. That's why we classify the conductor materials as good conductors and poor conductors of electricity, students. And one more thing is that, students, if you see that if you make the test with the tap water, in the case of tap water, students, the magnetic compass will show deflection, which means current is passing through the tap water, students. So that is the main thing, students. Our parents will warn you while you are touching the electrical appliances with wet hands. If you apply them with your if you touch them with your wet hands, so there is water, and the tap water or water or regular water is having so many minerals and all these things, and that regular water usage water is what it is good conductor of electricity, so that you will get current shock. That is the thing, students. So the tap water you are having is having several salts dissolved in it, students. Okay, that is the case. And on the other hand, if you do the with the distilled water is a poor conductor, students. So it does not allow current to these, students. Why? Because in the distilled water there is no salts. That is the case. So one more thing, if you add the common salt to the distilled water, it becomes conducting. That is the case, students. Now, most liquids that conduct electricity are solutions of acids, bases and salts, students. This is the important point. So liquids conduct electricity. Yes, liquids conduct electricity. And what liquids are conducting electricity? So the solutions of acids, bases and salts. So salt solution, base solution, acid solution, these solutions will conduct electricity, but distilled water will not conduct electricity. Okay, students, that is the case. So finally, what is our conclusion? Liquids conduct electricity. So current will pass through the liquids. Okay, that is the thing. Which type of liquids? Acid solutions, basic solutions, salt solutions. Now, whenever the current is passing through that liquid, does the electric current will shows any chemical effects on the liquid, students? So that is the second topic we are going to learn. That is chemical effects of electric current. Chemical effects of electric current. This is the case. So in the class 11th, 7th students, you have learned some effects of electric current, students. So can you think of those, students? So what we will do is that, students, we will do some experiment activity. So take the discarded cells, and from the discarded cells take out the carbon rods, students, and clean their metal caps with sandpaper. Take the metal caps of those carbon rods and clean them with sandpaper, students. Then wrap copper wire around the metal caps of the carbon rods and join them to a battery. So these are the metal carbon rods and the metal caps in the used out discarded cell, students. So to these metal caps we have winded the copper wire, students. So now these we called as the electrodes, students. Okay, and these two wires are connected to a cell or battery or whatever it may be. That is the case, students. So if you don't have the carbon rods, you can take the iron nails about 6 centimeters long also, students. Okay, and what we have to do is we have to pour the water in a plastic bowl, students, and you have to pour the salt or few drops of lemon juice, whatever it may be, into that water, so that that water will become solution and it will become conducting, students. Now we have to immerse the electrodes into that solution, students, and make sure that these metal caps are outside the liquid. Like that you have to make that, students, and you have to wait for almost 4 minutes, students. So what you will observe is that, students, near the electrodes you will observe some bubbles. Some bubbles will comes out, students. Why the bubbles will comes out? So in 1800, a British chemist William Nicholson has shown that if electrodes were immersed in water, if you place the electrodes in water and if the current is passing through that water, what happens is that bubbles of oxygen and hydrogen atom are observed. So oxygen bubbles and hydrogen bubbles comes out of these electrode, students. Okay. So where the oxygen bubbles will come? So oxygen bubbles will comes near the electrode which is connected to positive terminal, and the hydrogen bubbles will formed electron which is bubbles formed on the other electrode. That is the case, students. So the passage of the electric current is causing some chemical effects on the solutions, chemical reactions. That's when only the water is coming out, that's when only the hydrogen is coming out, that's when only the oxygen is coming out, students. So deposits of metal may be seen on the electrodes. Even, and one more thing is, if you see the electrodes, near the electrodes some metal deposits also occur, and color of the solution also changes. So these are the things: change of color, deposits of metals, bubbles. These are the chemical effects of the electric field, student, of the electric current. So the reaction would depend on what solution electrodes are used. What are the reactions is going on depending upon the what are the electrodes and what are the solutions you have taken, students. Okay, that is the case. So if you do an experiment, if you take a potato and place the two fluids into the potato, left for half an hour, what happens? You will observe a greenish spot in the terminal you have, terminal, students. That is the case. So every time you do this task, students, you will observe that greenish spot is near the electrode or the wire which is connected to positive terminal. That is the thing, students. So we are coming into the third topic, which is nothing but electroplating. What is meant by electroplating, students? Okay. So if you buy a new brand bicycle, you will observe that the cycle is very shining. It is having shiny handlebars, the wheels are shiny, and if you accidentally make some scratches, the shiny coating will removes. So the shiny coating is only upper side, upper surface. Behind that there is non-shiny surface, students. So can you get out how this surface, shiny surface is coated on that previous surface? So that is because of the electroplating students. So one metal is coated on another metal. Okay students, that is one metal is coated on another metal, that is because of the electroplating students. So for that we need what we need students, we need copper sulfate and 2 copper plates of size around. So we need 2 copper plates students, these are the copper plates, and what are the size, 10 centimeters into 4 centimeters, and we want copper sulfate solution, and we will take some water, distilled water students, and we'll add 2 tablespoons of copper sulfate to it students, and we will add a dilute sulfuric acid to the copper sulfate solution students. So finally, because after adding all these things, it will becomes more conducting, the liquid is more conducting, it will conduct the electricity students, current. So now we will place now we will place the copper plate students, copper plates, and we will connect it to a cell. So what happens, as this liquid is more conductor, so the current will passes as long as this process completes. What happens, if you see after the 15 minutes, if you remove the electrodes from the solution, what you observe students? So what you will observe is the students, so when the electric current is passed through the copper sulfate solution, that copper sulfate solution is there. Whenever the electricity is passed, it is the free copper gets, it is dissociates into copper and sulfate students, and this free copper gets drawn to the electrode connected to negative terminal. So this copper will goes to the negative terminal. So if it is the negative terminal, so it is the negative terminal, this attached to this electrode students. So the copper from the liquid or from this from this liquid or from this plate comes and attached to this negative terminal electrode students. If the process goes on, more number of copper comes and attached on these students. So if the copper comes on to this, what happens students? So already basically in the liquid there is copper and sulfate, copper sulfate solution. If the copper sulfate, in the copper sulfate, if copper is missing, how the solution is balanced? So the copper which is on this copper plate, so this will comes and dissolves in the solution, so that the solution remains same students. So thus the copper which is on this plate is comes and rests on this plate students. So this place gets more and more copper. So in this way, this is called as electroplating students. Okay, that is the case. So if you see all the shiny materials, all are because behind this shininess there are some other metal students, but because of the electroplating, so these are getting some another coating, another metal is coating on these elements students. That is the thing students. So thus the process of depositing a layer of any desired material on another material by means of electricity is called electroplating students. So one metal is deposited as a layer on another metal through the electricity passage, it is called electroplating students. So we will use it most commonly students, that is the thing. It is electroplating, very useful students. So what are the examples is that students, chromium plating is what, chromium plating students, that done on many car parts, bath taps, kitchen gas burners, bicycles, handlebars, etc. And chromium is having a very shiny surface and it is not corrosive students. Okay students, that is the case. And it is also, so it is the, but chromium is expensive students, and why because of that students, we will make the object with cheaper metal and we will give the chromium design students. Even the jewelries we will make also done with the electroplating silver. So rolled gold items, we call them silver and gold items, they are made with some other metals and there is a silver coating and gold coating, that is because called as electroplating students. That is the case. Even though we use the tin cans for storing food students, so it is also electroplating students, the tin into iron, that is the case students. So iron in the bridges, so it is very corrosive, that's why a coating of zinc is because of electroplating. So this is the whole chapter students. So finally our chapter is completed, students. Hope you have understood well. So don't forget to subscribe Sreenath Telugu Sreenath YouTube channel, students. So we have completed our journey towards this chapter, students. So we will see the summary of this chapter. So first thing is chemical effects of electric current, students. The three topics were covered here is do liquids conduct electricity, chemical effects of electric current, and electroplating, students. So first thing is liquids conduct electricity. Yes, students, the liquids are conducting the electricity. So for that we have made some testers, students, to test whether the liquids conduct electricity or not, students. And how the bulb is glowing is the filament in the bulb is getting heated. It reaches to very high temperatures because of the electric current, because of the heating effect of the electric current, that bulb is glowing, students. Okay, that is the case happening, students. And the thing is that, students, that liquids are good conductors, but sometimes the bulb is not glowing, students. So why? Because means liquids conduct the electricity, but it will collect very little current. That's why we need another tester, so which is developed based on the magnetic effect of electric current, students. It is like that, students, wherever the current flows, it will shows magnetic deflection in the compass. We use this thing, students. And final thing is that, students, every material can conduct, students. Even the insulators also conduct, students. That's why we classified materials into good conductors and poor conductors, students. Okay, that is the case. So under certain conditions, extreme conditions, poor conductors also works as good conductors, students. So that is the case, students. So finally, what is our conclusion, students? So acid solutions, base solutions, and salt solutions will conduct electricity very, very goodly, students. Okay, so distilled water is a not good conductor, students. Next thing is chemical effects of electric current. What are the chemical effects of electric current, students? So because whenever the electric current flows through liquid, students, it will cause some chemical effects, students. What are those? So if you see that in the case of a potato, there is a greenish spot, it is because of the chemical effect, students. And in the case of like this, students, you will observe the bubbles near the electrodes, which means there is oxygen involved and hydrogen involved. So this is the chemical reaction, chemical effect. And sometimes one metal is deposited on another metal, so that is the chemical effect. And sometimes color of the solution will changes, it is also the chemical effect. So all these are the chemical effects, students. Next thing is electroplating. So in this electroplating, what happens? One type of material will get deposited on the another type of material. So this is because of the passage of the electric current, students. So that is called as electroplating. That electroplating nowadays is used in many, it is having several applications, students. The process of depositing a layer of any desired material on another material by means of electricity is called electroplating, students. Okay. So chromium, we will see the chromium, students. So which is very having shiny appearance, students. It is not corrosive, and sometimes if you want to make the all metals with chromium, it is high cost. That's why we will give the chromium coating. And the bridges made with iron, students, and those bridges are also given the zinc coating. And the tin cans are giving the tin coating on iron. And the gold and silver ornaments are given, some ornaments are giving gold and silver ornaments, students, like that. So finally chapter is completed, our summary is also completed, students. Hope so you have understood well. Have a nice day, keep smiling. Bye bye, students.